Here we consider the case where we are taking a small sample from a population. In this case, we can use the rule that if we are sampling less than 5% of the population, then we can treat the selection of each as independent. If we think of them as dependent events, then it'll be calculated a little bit differently. So for instance, if I'm looking at a case where I have 3 car ignition systems that I'm sampling from 200. I know that 5 of those are going to be defective. And I want to know what's the probability that when I pick those 3 different ignitions from the sample of 200, that all 3 of them are going to be good. So assuming that they're dependent events, well, we can look at it as the probability that the probability that the first one is good. So if there's 5 defective, we know that 195 are good. So we have a 195 out of 200 probability of getting a good one. And assuming that we picked a good one out of the pile of 200, then we have 194 over 199 probability of getting another one. And then assuming that we got the first 2 are good, then there will be 193 out of 198 probability of that third one being good. So this gives us something around 0.926 probability of getting all 3 of them to be good. Now that's assuming that they're dependent, but in this case, because we had a small sample size, only sampling 3 out of 200, we could actually treat these events as independent events, and it wouldn't really change the probability significantly. So if I'm going to use the 5% guideline and treat them as independent events, let's see how that would turn out. In this case, if they're independent, each time I pick, it'll have the same probability of being good. And here, if I multiply these out, well, we get something very similar to what we got in the previous case, about 0.927. And so we see that our assumption that they were independent here actually got us pretty much the same answer, or up to one digit there that was off.